अच्छा डियर स्टूडेंट्स, अब चलते हैं अल्टरनेटिंग करंट लेसन 28. We finished alternating current from alternating current lesson 1 to lesson 27. From 1 to 27 AC lesson from 1 to 27 we finished the theory part of alternating current. From 1 to 26 and 27 I explained you how to add voltages if there is a resistance or a capacitance or inductor in series. Let us do this numerical, and through this numerical, actually through this circuit diagram where the resistance is 3 ohm, here is a capacitor of the capacitance is not known, its capacitive reactance is known. That is 4 ohm. What is capacitive reactance? When a capacitor is connected across an alternating source, it offers a resistance. That resistance is called capacitive reactance. Symbol is Xc. And this I had derived for you in previous lessons. Xc was equal to 1 by omega c, right? And similarly, there is an inductor having inductive reactance 8 ohm. Means this also I had derived the expression for XL. Inductive reactance means the resistance offered by an inductor when connected in an AC source. This was also previously derived as omega L. Omega is 2 pi nu L, right? So if you look at here and here, there is omega here, means 2 pi nu. Xc is equal to 1 by omega c. Omega is 2 pi nu c. So only if there is some frequency, and frequency is associated with an alternating EMF or voltage, then it has some value. Similarly, the inductive reactance, which is omega L, that was also derived in previous lessons. Omega is 2 pi nu L, and nu frequency is associated with an alternating source of EMF, and the resistance 3 ohm. This does not depend on frequency; it is material dependent. So let us. So there are 3 elements: resistance having 3 ohm, a capacitor having capacitive reactance 4 ohm, an inductor having a inductive reactance 8 ohm. They are in series, and here is a alternating source of voltage EMF 200 root 2 sine 100 pi t connected across it, across the combination of RCL. Now, so it is a series RLC circuit. It doesn't matter whether C capacitor is here or resistance here, they are in series, right? So what we have to find out? We have to find out all these 6 different things. What is the instantaneous current, RMS value of current and voltage across this, as well as this. Means RMS value of current across R, across C, and across L, and potential difference across R, C, and L. What is the power factor? Power factor I have already explained you in previous lessons, that is equal to your cos phi. So where phi is the phase difference between the voltage and current, here only voltage is given. So if you can find out an expression for current, from that we can find out also phi. Then what is the power input? This is to be found out. What is the resonance frequency? Resonance frequency I had derived in theory lessons, nu as equal to 1 by 2 pi LC, square root of that. So if we can find the value of L and C, then putting it here, we can find out the resonant frequency. And what was resonant frequency? When it was drawing maximum current. Then number 6, the impedance of the whole circuit, means the total resistance offered by this as well as this. Look, they cannot be added, don't think this is 3 ohm, this is 4 ohm, this is 8 ohm, so it will be added like 8 ohm plus 4 ohm plus 3 ohm, that is 8 plus 4, 12 plus 3, 15 ohm. It's not that way because that is what I have explained to you in lesson 27. Then current and power at resonance condition. Impedance, current and power at resonant condition. So let us begin with the solution. What is given? Given R is equal to 3 ohm. The value of this resistance is 3 ohm. And the resistance offered by the capacitor called capacitive reactance is given as 4 ohm. Xc is given as 4 ohm. And Xc is equal to 1 by omega c. And what else is given? The inductive reactance, that is equal to, and what else is given? The inductive reactance, that is 8 ohm. And the symbol for inductive reactance was XL, and that was derived in theory lessons as omega L, that is given as 8 ohm. This is 4 ohm, this is 3 ohm given, right? And what else is given? This is source of EMF, 200 root 2 sine 100 pi t. The EMF is given as 200 root 2 sine 100 pi t. Now, if you compare this with the alternating EMF, E is equal to E naught sine omega t. So, what is the conclusion? So, sine, this is your E naught. So, your E naught is equal to 200 root 2 volts. So, E naught is equal to 200 root 2 volts. And if you compare this part and this part, omega t, t here, so 100 pi is your omega. So omega is equal to 100 pi. What will be the unit? Radian per second. So that is the angular frequency. Now let us derive one by one. Let us find out instantaneous current, right? If the source of EMF is like this, 200 root 2 sine 100 pi t, that is E, this is the value of E at a time t, which changes with time. Let us find out the instantaneous current first. Now look, the video will be lengthy, but after all we will be solving these 6 different things. So you can think as there are 6 different numericals in a single numerical. So let us find out the instantaneous current. Now, in series RLC circuit, the total resistance offered by the circuit, RLC, was called impedance and the symbol was Z. And it was derived as R square plus XL minus XC square, square root of that, right? It is not like this. Don't think 3 ohm plus 4 ohm plus 8 ohm, that is equal to 8 plus 4, 12, 15 ohm, not that way. So let us find out how much is that. So your Z is equal to, resistance was given 3, square of 3, XL was given as 8, XC was given as 4, so 8 minus 4 square. So this comes out to be 5 ohm. Means this circuit, this value being 3 ohm, this value being 4 ohm, and this value being 8 ohm, as a whole, what total resistance they are offering? The total resistance, that is called the impedance, is Z, is found out as 5 ohm, right? So Z is equal to 5 ohm. Now, in previous lessons, I have explained you the impedance triangle. This is how it was. This was your phi, this was your R, this was your XL minus XC, and I had explained you why this is XL minus XC, why this is not XL minus XC. That I have explained you in theory lessons. And the square of this plus square of this is equal to your Z square. That is from here. If you square both the sides, Z square will be R square plus XL minus XC square. So it is a Pythagoras theorem. So this is represented by a triangle called the impedance triangle. So now from here, your tan phi will be perpendicular by base, that is XL minus XC over R. Now putting the values of XL and XC and R, I get it as 4 by 3. So phi is equal to tan inverse of 4 by 3. Just to put it in a calculator, this comes out to be 53.1 degree. So let us say this is nearly equal to 53 degree, right? So now is interesting. Now is interesting and very fundamental. Here XL is greater than XC. How? Because XL was given. XL was given as 8, XC was given as 4. So 8 is greater than 4. So XL is greater than XC. Means the resistance offered by the inductor is more than the resistance offered by the capacitor. Now, this part I will explain here. This part I will explain here with this angle to justify whether the current is ahead of the voltage or the voltage is ahead of the current, phase-wise, right? So let us find out the maximum current. So your I naught current is voltage by resistance, V naught. V naught, if you compare with the given equation, with your given equation, E naught or V naught, which I explained you here as the 200 root 2. So you can call it V naught or E naught, one and the same thing. 200 root 2 divided by the total resistance, that is called the impedance, that was calculated as 5 ohm. So this is your peak current. 5 cancels with this, so I naught is equal to 40 root 2 ampere, the maximum current. Now, what is the expression for current? Now, the expression for current, using the expression I is equal to I naught sine omega t. Now, whether here we will have a plus phi or whether we will have minus phi, that is to be understood, right? Phi we have already calculated, but whether that phi will be plus phi or minus phi, that will be explained from this diagram. Now look, so for a resistance, this part represents the voltage across the resistor. This part indicates the current. Why this I and V are in the same direction? Because we know when an alternating current is flowing in a resistance only, the current and the voltage across it, they are in phase. That we had derived in theory lessons. And now look, and your voltage across the inductor was leading by pi by 2. That is same thing as the current is lagging behind the voltage pi by 2 this side. This also we had explained in theory lessons. And so VL is represented to this side, positive y-axis, voltage across the inductor. Similarly, in a circuit containing a capacitor with an alternating EMF, we had also found out the current was ahead of the voltage by pi by 2. Or same thing, therefore, if this is current, that is same thing as saying the voltage across the capacitor is lagging behind the current by pi by 2 this side. So VL and VC are opposite to each other. From here to here is VL, from here to here is VC. So VL minus VC, VL, from here to here is VL, from here to here is VC. Now, so VL minus VC will be to this side. That is from here to here. So this from here to here is VL minus VC, from here to here is VR. So the resultant of this and this using parallelogram law will be this one. So this is your angle. So this peak voltage, that is V naught or E naught, and is this way, the current is this way. So you can say the current is which is to this side is lagging behind, therefore by 53.13 degree. So in the expression for current, since it is lagging behind, we will have to put a minus sign. So the expression for current will be I is equal to I naught sine omega t minus 53 degree. Right? That this part is important. Whether it is minus or plus, you have to understand from this diagram. So now put the value of I naught, which we just calculated. So I naught sine 100 pi t minus 50 degree is your current at time t. Current at time t means instantaneous current. Now then, coming back to the this part, IRMS. In theory lessons, I had derived you the RMS value of current was I naught times root 2. I naught we just calculated. That is 200 root 2 by 5, that is 40 root 2. So 40 root 2 by root 2, root 2, root 2 cancel, so 40 ampere. Right? So, and it is the same current passing through R, C and L because all these three elements in the circuit are in series. All these three elements in the circuit are in series. The same RMS current passes through all the elements. Now let us go further. I told you in the beginning the video will be lengthy, but moreover you will be solving at least 6 numericals. Now then coming back to VRMS across the resistance. RMS value of the voltage across the resistance. Any voltage is current into resistance. This current IRMS is flowing through the R. This IRMS is flowing through the capacitor. This same current is flowing through the inductor. So current into their resistance, current into the resistance will be the voltage. So VRMS across R will be current into its resistance. This we found out as 40, R is given 3, so 120 volt. Similarly, potential difference VRMS across the capacitor will be the current flow passing through that times its resistance. This is given in the question as 4. So 40 into 4, that is 160 volt. Then VRMS across the inductor will be current into resistance is voltage. So we require to find out VRMS. So we have to take IRMS. So current IRMS into XL. This is also given in the question as 8. So 40 to 8 is 320 volt. So then comes your power factor. Power factor I have explained you in theory lessons. If you watch my video carefully, it was cos phi. Phi we have calculated. So cos of minus 53. We have to be careful here because from here I just explained you this angle is phi. This angle is phi. To this side means current is lagging behind. Therefore, phi is negative, minus phi. So, phi is negative, minus phi. So, cos of minus 53 is your power factor. That is equal to, if you put it in a calculator, this comes out to be 0.6. Now, then coming back to power inputs. Power inputs. Any power. In current electricity, we derived many expressions for power. In current electricity, when only resistances were there and a DC source was there, DC source, power was equal to VI, V is equal to IR, I square R, I is equal to V by R, V square by R. These were for DC circuits. In AC circuits, this V changes with time, this I changes with time. And power I had derived, P is equal to VRMS, IRMS into cos phi. VRMS is equal to 200, IRMS calculated, cos phi calculated, so this comes out to be 4800 watt. You might ask how VRMS is 200, you might ask it here. So if you look at here, if you look at the first phase, this is your E naught, 200 root 2. E naught is equal to 200 root 2. And I have already told you E RMS was equal to E naught by root 2. So you can write E naught or you can write V naught, one and the same thing. You can write E RMS or you can write V RMS, one and the same thing, right? So E naught is given 200 root 2 divided by root 2. Root 2 cancels. So V RMS is 200. So your V RMS is 200. So that is why I have put 200, not 200 root 2. 200 root 2 is the maximum value of the voltage as given in the question. So 200 into 40 into 0.6 comes out to be 4800 watt. Now, so since E is equal to this is what I have explained. E is equal to E naught sin omega t, or you can write V is equal to V naught sin omega t, one and the same thing. If you compare here, V naught here, compare with this. So your V naught is this, 200 root 2, and V RMS is equal to V naught by root 2, so that is equal to 200. Therefore, 200 is put here. Then coming back to 2 more pages. Then coming back to resonance frequency. In series RLC circuit, resonance frequency I had explained you. We had our impedance Z was equal to R square plus XL minus XC, square of that times square root, right? Now, if XL was XC, then this minus this is 0. So your Z becomes minimum. So it draws maximum current. So this is the condition. Resonance frequency is the frequency during which the circuit was drawing maximum current. If it has to draw maximum current, then its resistance should be least. And the resistance should be least, that is minimum. When this is equal to this, then this part will go. We will be left with R only. So by putting XL is equal to XC, this was derived in theory lessons called resonant frequency. Now to find out this resonant frequency, let me put it nu naught. We have to find the value of L and C. But it is given XL is equal to 8. XL. Inductive reactance is 8. And this is omega L. This was also derived in theory lessons. So from this, L comes out to be, omega comes to this side, 8 over omega. And omega is equal to 100 pi. Omega is equal to 100 pi, right? If you look at the applied EMF, if you look at here, this is omega 100, omega t. So omega is 100 pi. So your L comes out to be this. Now put this value of L here. Now we are required to find the value of C also. Now it is also given the capacitive reactance is 4, and capacitive reactance was derived in theory lessons as 1 by omega C. So cross multiply this, 4 omega C is 1, so C is equal to 1 by 4 omega. 4 into omega. So this is the value of C, and this is the value of L. L means this much Henry, Henry. This means this much farad, F-A-R-A-D. So you put this value of C and this value of L here. So your resonance frequency, which is 1 by 2 pi LC square root of that, just put the value, this comes out to be 35.4 hertz. Means at this frequency, the impedance of the circuit will be minimum, that is equal to, that is Z will be minimum, that is equal to R, that is equal to, given in the question, R is given in the question as 3 ohm. In the question it is given as 3 ohm. And for what is the meaning here therefore? So the resonance frequency is found out, 35.4 hertz, means at this frequency the circuit will draw maximum current. Means for nu is equal to this, current will be maximum because the impedance is minimum, that is just equal to R. Now the last one, then sixth one. during resonance, what is impedance, what is current, and what is power during resonance. And look, when there is resonance, when it draws the maximum current, because its resistance is minimum. So we know, I just discussed, the impedance was R square plus XL minus XC square, square root of that. And when this XL is equal to XC, means the resistance offered by the inductor and the resistance offered by the capacitor are equal in magnitude, then this minus this will be 0. Square of 0 is 0. 0 plus R square is R square. Square root of R square is equal to R. So during resonance, your Z will be minimum. So if the resistance becomes minimum, it will draw maximum current. So that is what I am saying. When XL is equal to this, Z is equal to minimum, that is equal to R. So impedance is equal to 3 ohm. So during resonance, the impedance is equal to 3 ohm, right? Now, then current through the current during resonance, right? Current during the resonance. Now, so IRMS is equal to VRMS over R, that is equal to 200 by 3, this many ampere. Then power during resonance will be P is equal to the expression for power. Look, you might ask you why there is no cos phi term here. You might ask here why there is no cos phi here. Now, I had explained you during resonance, and this was your phi, this was your Z, this was your R, this was your XL minus XC. When this phi was 0, means when XL is equal to XC. If XL is equal to XC, this side representing XL minus XC, this side will be 0. The length of this side will be 0. If the length of this side becomes 0, then this phi will be 0. Phi will be 0. I should have write cos phi here. Cos phi. Now phi is 0, right? During resonance. So cos 0 is 1. So 1 into this thing is only VRMS, IRMS is the power during resonance. So VRMS was calculated, IRMS was calculated, put the values, it comes out to be 40,000 over 3 watts, right? So it's a lengthy video, but go through it time and again. Then alternating current will find, solving numericals from alternating current will find it very convenient for you. So that is what it is. I will upload few more good videos solving numericals. Okay.